Okay, and closing out our finding limits analytically, we need to talk about piecewise functions. So in general, you can still do direct substitution for any of the parts of a piecewise function. So you can directly sub into any one of the equations as long as you're dealing with x values that are in that domain. But where you're going to have a problem is a breakpoint. So you could not just directly sub in for x equals 3, let's say, here, because the equation changes at 3. So what's happening on one side may not be the same as what's happening at the other. So at these points, at the breakpoints, you need to calculate the one-sided limits. You've got to do the limit from the left and from the right, and then compare them to see if they are equal. Okay, just for breakpoints. So let me make this real clear. I know it's not on this one, but if I were to try to find the limit as x approaches, let's say 5 of this equation, I would go 5 is not a breakpoint. 5 is firmly in this domain. So I would simply just plug in the 5 to the applicable equation, and I'd have the square root of 18, or 3 square roots of 2. So the direct substitution does not change except for these two numbers. So I'll start with one of them. Let's do the -2. Okay. This says find the limit as x approaches -2 of f of x. Well, I have one equation that applies for x less than -2, which would be when x is approaching -2 from the left. And I have another equation when x is greater than -2. So that would be when x is approaching -2 from the right. So I am going to write these two things separately. And again, it's going to make a big difference how you write it. If I'm going from the left would be when x is less than -2. So it would be this equation. And if I am approaching -2 from the right, that would be when x is bigger than -2. So it would be this equation. So, excuse me. It's very important that I'm writing the correct equation with the correct notation. And it is not okay for you to just skip this notation altogether. You need to include all the pieces of what you are doing. So when I approach -2 from the left, I get 1 over 0, which tells me that this limit does not exist. And in fact, if I look at something like maybe a -1, sorry, if it's less than -2, it would be like a -3, I would have a negative number. So this is actually approaching negative infinity on this side. Whereas if I approach -2 from the right and I do direct substitution, I would just have 4 minus 5, which is -1. So clearly, these two things are not equal to each other. So I would conclude that the limit as x approaches -2 of this function f of x does not exist. And that is again because the two one-sided limits are not equal. So outlining the expectations one more time, you are writing down which of the one-sided limits you're finding. You're including the function that goes with each one-sided limit. You're drawing a conclusion for what each of those one-sided limits equals, and then using that together to determine whether or not the two-sided limit exists with a specific reason why that's the case. Okay. So I'm going to have you try the second one. the limit as x approaches 3 of f of x. Same function, slightly different x value. Go ahead and press pause and give it a try. Okay, so how'd it go? Check your notation. When we approach 3 from the right, that would be corresponding to the radical equation, because that's when x is bigger than 3. When we're approaching 3 from the left, that would be when x is less than 3, so that would correspond to the polynomial. In both cases, direct substitution gives me the same number, so I can conclude that the two-sided limit is equal to 4, because I can clearly see that both of the one-sided limits are 4. Okay, so part of what we are outlining with this is documenting your process and reasoning with correct notation. If I were to look at a problem and you had just kind of scribbled something like that's not going to cut it. Okay, I don't know, I cannot see that you understand what you're doing or why you're doing it, so you need to be sure to include correct notation. Okay, so we're going to end this lesson with a general strategy for finding limits. We've talked about a variety of different strategies, but we want to make sure that you kind of know when to use what. So what do you always start with? Direct substitution. Plug it in, and if you get a number, you're done. Okay. However, if that doesn't work, I will add that you might want to look at simplifying first. So I know it was one of the later ones we talked about, but if possible, simplify to one simple fraction. I mean, one numerator, one denominator. So if you have a complex fraction or a sum of things, separate terms, it's not all just one fraction, try simplifying it first. Okay. Now, if direct sub results in a number over 0, okay, use a graph or a table of values to determine if it's going to go to positive infinity or negative infinity. So we know that a number over 0 is going to be an infinite result. And so you're going to try to figure out which way it goes. If it results in 0 over 0, you have a couple of different options. So you can try factor and cancel if it's factorable. Okay. Or you can try to multiply by a conjugate. Okay. And this is assuming that you have already done step 2, which is simplify it as much as possible. Okay. If you haven't done that yet, then you definitely want to do that as well. Okay. And then last but not least, for a piecewise function, you must do one-sided limits for any breakpoint. So if you are approaching an x value where the equation changes from one equation to another, then you've got to do the one-sided limits and then compare them. Are they the same or are they not? Okay, so then the very last thing that you're going to do is you're going to do some strategy identification practice. So for each one of these, what I want you to do is determine which strategy will be the most effective to evaluate it. So before you actually do every single evaluation, I want you to just try, plug in, do your direct sub first. If that works, great. If not, then identify which of the strategies that we've talked about will be the most helpful. And then go ahead and evaluate the limits, and you can find the solutions to these on our Canvas page.